I'd like to thank the committee for inviting me to talk today. My work is mainly on the capillary electrophoresis and profiling and authentication of herbal medicines. I'm an analytical chemist, so I'm quite keen on developing profiles for various herbal medicines and trying to use statistical analysis to authenticate them. Herbal medicines still have a traditional reputation of safety. The nomenclature of plant species can lead to problems in what you get over the counter in some areas. Also problems with the active ingredients, the quality, and unfortunately, substitution of individual ingredients as well. In the UK now, herbal medicines have to meet a specific safety and quality, and the MHRA has introduced from the 30th of April that all manufactured herbal medicines will have to be authorised to be sold in the UK. This means that they will no longer be able to sell unlicensed herbal medicines in the UK. However, herbal medicines can still be bought off the internet and sometimes can be There are some weaknesses in the public health protection given by this regime. Remedies supplied are not subject to specific quality or safety. We need some way of checking that the medicines we get or buy are safe. I'm going to be talking mainly about a specific genus of plants, namely Scutellaria. This is sometimes known as skullcap, and we bought various samples of Scutellaria from locations around the world, and the medical uses of Scutellaria are as follows. Used as an anti-inflammatory, antioxidant, anti-cancer, antiviral, and antibacterial. My main aim was involved in the antioxidant side of the Scutellaria. Scutellaria constituents these are the main ones: biquilin, bicalin, woganin, scutellarian, oroxalin, viscodulin, and woganside. In my analysis we do not actually measure any of these specific components as such. We buy the sample from the herbal practitioners or the internet, and we powder them in a coffee grinder. We extract the samples with acetic acid using ultrasonication for 60 minutes. For the capillary electrophoresis side, we need to add an internal standard, in this case, flavone itself. The samples are then filtered and made up to a specific volume with a buffer. These are the samples purchased, as you can see, from around the world. The Amoena was purchased in China. Scutellaria bicalensis, an authentic sample, and another sample was purchased in China. During holiday periods in Thailand and from friends in Thailand, we got 7 samples, and from the UK, we got another 7. Another sample was purchased in Malaysia, and Lateriflora samples from UK and America. I don't know if all of you or any of you are familiar with capillary electrophoresis, an analytical technique for the separation using electroosmotic flow. And this gives us various parts of the system. We obviously need a detector because we're going to measure the UV characteristics of each of the samples. Our samples are injected through these vials and we get separation. The technique I am using is called a sweeping method. It uses a silica column and with a various complicated running buffer. I inject samples by applying a pressure, and as you'll note there, quite a long time. Normally, capillary electrophoresis only uses a very small time. Our detection we do at 200 nanometers. We are using the 200 nanometers to detect as many compounds as possible. And to do the running, we apply a 25 kilovolt voltage. Our sweeping process, we have our buffer in the capillary. We inject our sample, as shown in the yellow part. That's only under pressure. We then apply the voltage, and the band is swept into a very narrow band, and then allowed to separate. The separation can be governed by the amount of methanol in our mobile phase. This is an electropherogram of the Scutellaria bicalensis. You will note that some of the peaks are very high. We were trying to develop a complete fingerprint of the sample, so we wanted to see the smaller components as well. So that is the bicalensis. The lateriflora, you will note, looks fairly similar. To try and differentiate them without just looking at the samples, we apply multivariate statistical analysis. And this helps to visualize large amounts of data. We can use two types, unsupervised or supervised. Unsupervised means, first of all, you have no knowledge of your samples. And in our analysis, we are going to focus on hierarchical cluster analysis, HCA for short. Once we know the groupings, or when we know the groupings that they have, we can apply another technique, this time called SIMCA, Soft Independent Modeling of Class Analogy. And this is going to allow us to make predictions. For all the samples, we need to get some statistical analysis for them. We have to make 10 extractions of each sample to give us some variable data. As we said previously, no attempt was made to identify individual components. So none of the bicalin, bicaline, woganin were actually measured essentially. We measure relative migration times and relative peak area using the internal standard flavon, and we noted 28 peaks for the chromatograms, or the electropherograms. And we use an Excel spreadsheet. We use a software called Pirouette to do the hierarchical cluster analysis. And on the screen, you will see various, what they call trees and branches. You can set the similarity as noted by the dotted line. And we had 3 different species, Lateriflora, bicalensis, and Amoena. And if we set that, all our samples fell into the correct area. I say that unfortunately, it didn't all fit. One of our samples actually matched up with Scutellaria lateriflora instead of Scutellaria bicalensis. As I said, we can adjust the similarity. This time, this figure shows you we have got 4 groups. And they can match up to samples bought in various locations. So the Thailand samples were all clustered together. Samples purchased in Malaysia and Glasgow also matched up. The unfortunate information we didn't have at this time was where the samples were grown, when they were harvested, and their age of samples. So we could have grouped them into any amount of samples. What we did after this is plot them in the 3 groups on a 3D plot, the Simca. And you can see the 3 groups are well separated from each other. And we can use this to make predictions. What we do is split the data into 2 groups, training and unknowns. And this training set is used to build a model which we can use then to predict what the sample class is. When we did this, we got very good predictions of our unknowns, on average 94% correct. As I said previously, one sample was actually included with lateriflora. The sample purchased was sold to us as Scutellaria bicalensis, but unfortunately in our analysis it matched up with lateriflora. So we may have been sold the wrong species as such. I think I'm well ahead of schedule here, so maybe good. Our conclusions: CE and multivariate statistics was able to differentiate different Scutellaria species. The method also identified a sample in the wrong grouping or was sold wrong to us. Finally, it may also be possible to identify samples grown in different locations, when they were harvested, and the specific age of the components. This would obviously take quite a lot of work, and we are still continuing to analyze herbal medicines using analytical techniques, chromatographic techniques. I would like to acknowledge a few people, especially Professor Jindawan Boonskal from Thammasat University in Thailand, Dr. Suzanne Boyle, formerly of the Robert Gordon University, now in Manchester, and Dr. David Durham from the Robert Gordon University. Thank you for your attention, and I will happily try and answer any questions you may have. Thank you.
Do we have any questions?
Yes, let me start. Professor Reid, thank you very much for your pretty illuminating and innovative type of study. I just want to mention to you historically that I was at the University of Edinburgh 1968 as a fellow of the Medical Research Council of Great Britain, at that time still called Great Britain, not United Kingdom, by the way. But that's a side way. I think you're doing a great job. But my question is, have you tried any of the Croatia, I have difficulty pronouncing it, any of the items that you mentioned, anti-cancer, Of course, your interest is antioxidant. So have you done any preliminary work in that area yet?
We have been doing work on the antioxidant side of these compounds. I have not done any of the other studies on these areas. I was only trying for the authentication and develop profiles for these three samples and see how we could match it up with other herbal medicines. We have worked with other herbal medicines, and my colleague will speak about them tomorrow and things on that area.
Thank you very much. Very interesting. Very interesting. But which is the ill of the process? Ill. The ill of the process.
Yield?
Yes.
What do you mean by yield? I don't understand
The rendiment. Outcome. Ahí está, outcome.
Okay, the outcomes, what we are trying to prove is that you need to know if the species you had is the correct species, essentially. We're trying to show that we go and survey various shops, and are they selling the correct ingredient? Or are they selling Scutellaria lateriflora, Scutellaria, other types of species, essentially? You maybe pay good money for one type of the Scutellaria and get a different product. And that's what we're trying to show.
Yes, but is more sensible than an HPLC because these compounds must be analyzed by HPLC because are charged. Yes? Because of the, wait. Because of the way of extraction and because these are flavonoids. Yes? They are ionic.
Yes?
Well, this process that you developed is more sensible than the HPLC?
I have done the HPLC. I have done HPLC analysis of these compounds as well. Capillary electrophoresis is a much higher efficiency separation method than HPLC.
Yes.
So we can separate compounds much better using capillary electrophoresis than we can using HPLC. And that's why I went down the line of capillary electrophoresis, just for the higher separating power.
Because it's possible to make a fine analysis if you have an HPLC MS. You see?
Yes.
Then you can analyze each of the compounds.
Agreed, but I was of no need to identify any component. All I was trying
No.
to do is get a profile and use that profile to...
Yes, because I think that there are some methods that are easier. For example, a TLC. For example, on TLC.
Looks like Dr. Suzanne want to counter defeat.
Hello? May I just add one or two comments? Tomorrow we will speak about HPLC and we'll speak about measuring antioxidant capacity in the same herbs. What Raymond was doing was looking at a method of showing maybe adulteration or authenticity, and he picked up in CE because he said it's very efficient, but it's also very fast. So he's achieving his resolution or separations in less than 5 minutes. The comparable HPLC method was taken 45 minutes, so we'll show that data tomorrow. So we were answering two quite separate research questions, and we'll address the second set tomorrow afternoon. Thank you.
Looks like that's the answer looking, Martha looking. You got the questions? Okay.
Just one just a question. I wanted to know whether you could subject any fingerprint for the same type of cluster analysis or a PCA. You could apply, I mean, so essentially you need to generate a data bank of fingerprints to be able to authenticate it?
Yes.
Okay. Okay,
That's
thanks.
what we're hoping for anyway.
Okay, thanks.
Thank you.
Thanks a lot.
Thank you so much, Dr. Raymond. That was a very nice presentation and definitely a very interactive session as well. Now we'll move on to our further presentation. I kindly request Dr. Raymond to please collect your certificate from our chair and co-chair before moving on to the further presentation. Please give him a big, big round of applause.